Good morning, guys. As you know, today is I'm taking my last personal day. So you have Mrs. Wilson here with you. She taught at our school for, I think maybe 20 years. So she just retired last year and she's fabulous. So she's going to be here with you today, and she's going to play this video for you, and then she can pause it to allow you to do your work. So you guys are going to be doing three things today in class. We're first going to go over the cell respiration review that you guys did last class period. We're going to go over the answers for it. Then you have some time to play a Kahoot. And I think for this, I don't think I can give Mrs. Wilson my login. So I just did it so you could play it at your desk. And then you should have time to get through one of our very last assignments in class, which is called Energy Pyramid Slides. So go ahead and open up to begin with your cell respiration review, which you guys did for day 7. And I have one of your classmates pulled up right here, and we'll just use hers as an example. Okay, so remember when talking cell respiration, this is the process, excuse me, that you do. This is what you do to obtain your energy, but all life does it. So plants do it too. So when you were talking about how the three things that plants could do with the glucose they make, you said they could use it, they could store it for later, or they could use it to grow. Well, when plants use it, how do they use it? They go through cell respiration. Okay, so with that in mind, this one looks great. So during cell respiration, the one that you do, you eat glucose, you breathe in oxygen, and why do you do that? For energy. When you break down glucose, you break it down to CO2 and oxygen, or excuse me, CO2 and water. So this one looks great. Okay, let's go on to the next slide. You didn't necessarily have to use these here. I was only looking for you to fill in the boxes, but I put some extra words there for you to try to choose between. But let's take a peek at it. Light energy is captured in process of photosynthesis, which stores energy in glucose and can be used in a process of cell respiration. Since she has them here, I'm going to see if her other ones make sense. During photosynthesis, you take in carbon dioxide and water, so those make sense there. And during photosynthesis, you turn those into sugar and you create oxygen. So technically, the way she has those in there, those make sense. Okay, this next one. A student was asked what cell respiration is, and they said it's breathing. So right there, the student has a misconception that cell respiration and the way that we use respiration are the same thing. They are not. If you're calling respiration breathing, that's just this. So is that the same thing as what happens at the cellular level? No, but they are definitely related. So I'm going to just read hers. I disagree. Cell respiration is a process of glucose being broken down to release energy. We breathe to get oxygen in order to cell respirate, and it does keep us alive, but it is not cell respiration itself. You got it. She has the keyword releasing energy there. She's telling the differences. Yeah, you disagree. They're not the same thing, but they are related. You take in oxygen so that you can break down glucose for energy. Okay, so next you did your model analysis. So which model did you all like best? We had model 1, model 2, model 3, and model 4. Okay, so just as a show of let's see what our class liked, raise your hand if you liked the cow the best. Okay, usually it's about no one. Usually people give this 1 to 2 stars. All right, now this next one. Anybody like Model 2 as their favorite? Raise your hand. Take a look around. In my A-Day classes, there's a few people who like this one. They liked that it was a visual of the chemical reaction. Okay, Model 3. Who liked this one? Raise your hand. In all of my other classes, if you are like them, this has been the most popular model. People said that it would be confusing, however, if you didn't know what you knew. So if Mrs. Wilson is looking at this for the first time, I'm just curious what she thinks, because she's looking at it with new eyes, similar to the way that you would look at it. But I would think it'd be kind of confusing. So maybe you could pause the video and ask her, and then one of you could explain it to her, could break it down. Okay. What we do enter here is the mitochondria. So you guys have probably left middle school learning that the mighty mitochondria is the powerhouse of the cell. So what the mitochondria is, what the mitochondria is an organelle where cell respiration takes place. So if you know cell respiration is the process that releases energy, and it occurs within the mitochondria, it kind of is the place where energy is generated. So that's why they call it the powerhouse of the cell. All right, lastly, did anyone like Model 4? Raise your hand if you like Model 4. I thought my math brain people would maybe like this because it's very much like a math equation. You start out with these atoms, they rearrange into these. You can see energy stored in the bonds. You can see energy is released as heat or motion over here. This is like what you're going to be doing next year in chemistry. So this is an example. This is more of the bio version of a model, because you're getting into the where it occurs and the cells. The chemistry is more the actual movement of atoms and the energy that goes in and out of that. So if this one speaks to you, that's going to be along the lines of what you're going to be looking at in chemistry next year. Okay, and then the Baju divers. How crazy is that? So they spend 60% of their workday diving without oxygen to deep depths. And it's all because they have a 50% larger spleen. Most of us didn't even know what a spleen did, right? Could you point to your spleen right now? I didn't pull this up, so let me pull this out. Most of us couldn't. Most of us, some people point to their head when I did this in class. But here's your spleen. So your spleen is on your left side, and it is behind your stomach. So you'd have to lift up your stomach, and it kind of lays underneath. This is a lung right here. It lays underneath of your lungs. So if you would to point to your spleen, you would point to your left side, kind of behind your lower ribs. That's be where your spleen is. And as you read, these divers are actually born with, they don't develop, they are born with an enlarged spleen, which has the ability to shoot out more red blood cells into their bloodstream to increase their oxygen supply so they can still cell respirate as they're diving. Very cool. So this is an example of natural selection, an example of how those that are born with this enlarged spleen have advantage. Okay, so let's go ahead and close out of that, and then we'll move on to our day 8. So go ahead and open up your day 8 agenda, and Mrs. Wilson, if you would like to give them 5 minutes to play the Kahoot on their own. So they'll click on this hyperlink and they'll put in this pin, and they're going to do a Kahoot, which allows them to review for their photosynthesis and cell respiration quiz that they're going to have the next time I see them. So it's a multiple choice and short answer quiz. that they'll do at the beginning of next class period. So go ahead and pause the video, wait by 5 minutes, and let them play that on their own. Okay, there was one question on there that I was good if you were live. It was the ATP one, not all the photosynthesis, but what they call the energy in the body is called ATP. You do not need to know that, but that was just a little add-on for some of you that have maybe seen that in some of the models. Okay, the last thing, you have the rest of class period to work on your energy slides from day 8. So go ahead and open them up. And this is kind of pulling together a couple of the topics that we've learned. So we've talked about cell respiration, we've talked about photosynthesis, and we have in the past talked about energy pyramids. And an energy pyramid is a model for an ecosystem. And what you're going to be doing today is some calculations. You're going to be comparing 3 different ecosystems, and ecosystems are labeled as A, B, and C. So how are you going to view the ecosystems? You're going to view the ecosystems in an energy pyramid, because that is a model or a description of an ecosystem. So all you're simply going to do is work through with the rest of the time in class, you're going to work through the slides, and you will type these separately, but you are welcome to work with them in groups so you can discuss them with each other. So here is ecosystem A and ecosystem B, and we're going back to looking at how much energy is transferred between each tropic level. So you have your producers always on the bottom of your energy pyramid, and then you have your primary consumers, secondary consumers, and tertiary consumers, if there are any. So what we've learned in the past is just in general, the percentage of energy that's transferred from one tropic level to the next is about 10%. So what does that mean? Only 10% of the energy an organism eats actually gets transferred into its biomass, into its body, which makes sense. Think of all the food that you eat and how much of it does or does not go into your body. You don't gain the amount of food, the pounds in the food that you eat per day, because you burn that energy. So that's theoretical. That's like on average. Now you're going to actually calculate how much energy is transferred. So it says study these, and then on the next slide, you're going to answer questions. Anytime you see pyramid A and B, so like you see them here, they are the same as the ones before. So I thought maybe you could see the numbers off here. If they're too small, you can always go up to the slides before it. So it wants you to calculate how much energy is transferred from sunlight to producers. So I took the energy transferred to the producers and put it on top, and then the energy that the sun releases and put it on bottom. And then to get that as a percent, after you divided those two, you multiply that decimal times 100. So when I put this divided by this into my calculator, I got 0.86. And then you multiply that by 100. So you move the decimal point 2 places to the left, round to the nearest percent. And 86% of the sunlight that hits the ground in that area is actually used by the producers. So that number isn't 10%, but that's not in your energy pyramid. That's not transferring from organisms. That's just how much of the energy those plants are able to utilize. So for some reason, about 14% is not able to get utilized. Okay, so you're going to go ahead and do the same calculations here. And then down here, to get your average energy, you're going to take the percents. You don't have to put the percent in, you put 86. Let's say this is like 8 plus 12 plus 15. Add those all up and divide by 4, and that would give you the average percent. So you're comparing pyramid A to pyramid B, and then you're going to answer some questions about it. And then finally, the second portion is you get an additional energy pyramid, pyramid C, and you're going to do that same calculations. Okay, so when you're done, you are going to connect this to what we've been learning so far. Okay, good luck. If you have any questions, feel free to email me. But I hope you have a good start to your day. This is the end of the video.